Good morning, everyone, and welcome to Introduction to Machine Learning on the Cloud with Apper. And we are so happy to have every one of you here today. Welcome also, and we'd like to thank our partners, Kubo Philippines and PH Startup Week 2020. So before we do start, I'd like to give a quick intro of what we have for you today and our coach profiles as well. Let me just share my screen. All right. So once again, I am Sal Cruz from Apper.ph, and we are so happy to welcome all of you into our intro to machine learning on the cloud. So just a brief background of who we are and what we do. Apper Digital Inc., we are a multi-cloud digital innovations company. And our team, despite being small, we use our strategic partnerships as we merge strategy and deliver to improve the core offerings of our clientele. As you can see here, these are some of the certifications that our team has collectively up to date. And the mission is to bridge the knowledge gap for digital innovation, thus making the Philippines as a center of excellence, which is so perfect for the theme of PH Startup Week right now, with startups powering up the new normal. The goal of Apper is to really bridge that knowledge gap and bring digital innovation to all. So our team, while small, has the talent, skills, and experience to accelerate cloud adoption for businesses. And here are some of our valued partners. We have, as you can see here below, we've worked with some brands such as Globe, Beauty M&L, and of course, we are partners of AWS, Google Cloud, and Microsoft Azure. And now I'd like to introduce our coaches who would be with us today. We have, of course, Diwa Del Mundo, Apper's co-founder and principal cloud architect, and is an AWS certified for AWS machine learning specialty. And Wawi is, aside from being the co-founder and president of Apper.ph, he is one of the pioneers in the fintech and cloud computing industry market with over 15 years of working experience and has established himself as a country expert in security, payments, and cloud architecture. And he currently holds 10 cloud certifications with 3 specialty and 2 professional certifications from AWS. This is currently the most number of cloud badges in the country. Also today, we have with us Mr. Joshua Arvin Lap, AWS Machine Learning Hero, CTO of Complete Business Online, Insights, and Jepto, and of course, AWS Certified Machine Learning Specialty. So Arvin is the CTO of Complete Business Online, and he previously served as the director for software development and engineering for multiple startups. And of course, in addition to this, he has contributed and shared talks on machine learning and serverless engineering in international conferences like PyCon Malaysia and PyCon Thailand. And of course, to help bridge the gap between reality and expectations on applied machine learning and machine learning engineering. So we have an exciting session for you. Of course, brought to you by our wonderful coaches. So without further ado, I'd like to give the floor over to our first speaker, Mr. Diwa Del Mundo.
Thank you for the warm introduction, Mo. Kamusta kayo? I hope you're doing well despite the challenging times. I'm honored to give an opportunity to share with you my experiences in leveraging the cloud in building intelligent applications to help jumpstart your machine learning on the cloud journey. So let me first introduce myself. My name is Diwa Del Mundo. I am the president and principal cloud architect of Apper, a multi-cloud digital innovations company. I have a decade of experience working with cloud technologies and have worked with startups extensively as a software developer. Apart from my professional pursuits in the cloud, I was a cloud community leader of the AWS User Group Philippines from 2014 to 2019. The AWS User Group Philippines community has helped thousands of Filipinos better understand AWS through various activities like meetups, workshops, and other engaging activities. I am a passionate learner of cloud technologies, which resulted to my quest of earning AWS certifications. My certification journey started back in 2014, and in fact, I'm one of the first few in the country to have received the AWS Certified Solutions Architect Associate certification. Since then, I have gained a lot of certifications, including the professional associate ones, and also specializations for machine learning, database, and security. My career progress and grew with the cloud, starting with my work in Singapore-based Viki.com way back in the early 2010s, where I work as its video player, video transcoding, and backend services engineer. I have used cloud services such as AWS EC2, RDS, and Elastic Transcoder. After a couple of years, I decided to go back to Manila and participate in our local startup ecosystem. Eventually, I joined PayMaya, where I helped architect, build, and grow payment platforms such as PayMaya Checkout. And after almost 5 years in the fintech and payments industry, I decided to help build more innovations by establishing Apper. And through Apper, we can help you scale your business through cloud services. So as our tagline in Apper, we bring the cloud to all. So let's start talking about machine learning on the cloud. So you might have joined this webinar hoping to get an idea of utilizing machine learning on the cloud. So on that regard, you're starting your journey. Or you might have joined this webinar because you might be using machine learning already in your work or in your company, but you want to utilize cloud services. So I'll be happy to guide you and better understand all of the innovations that we can find with the cloud in helping you build more intelligent applications. But before we deep dive into that, so let's start with the basics first. So let's first define what is machine learning. So essentially, machine learning is the ability of systems to learn and improve without explicit programming. It's generally seen as a subset of AI. So when we say AI, essentially it means that the machine exhibits human-like intelligence. For machine learning, the end goal is to predict, and the output of the process is to produce a model. Machine learning was defined way back in the 1950s. So it has been around for quite some time already. But it gained a lot of interest and popularity during the 2010s. So you might ask, okay, so if it has existed for quite some time, how come it became popular this past decade? So there are a lot of factors. So we have improved and more efficient algorithms. So having more advanced algorithms allowed a lot of innovations and use cases to be realized. At the same time, having more powerful hardwares, particularly GPUs or graphic processing units, allow the execution of the operations to run machine learning models very fast, which allowed the innovations to prosper. At the same time, the availability of data is critical to make sure that you have accurate machine learning models. Because of the rise of the internet and also cloud computing, it allowed companies to collect data, which resulted in more accurate and more meaningful machine learning models. So to better understand it, so let's have a scenario. So let's say you are working for a payment processing company, and you were tasked to develop a service to determine if a transaction is fraudulent or not. So how would you do it? The obvious approach is to create a rule-based system to determine fraud based on parameters and a set of rules to make a decision. So let me put it into code. So you'll see here that I wrote some code to model a rule-based decision engine to determine if a transaction is fraudulent or not. So most likely you're going to have a fraud score. So at the start, it's going to be 0. And you have a flag here to determine the state of the fraudulent state of the transaction. So initially, we can set that to false. Now, you can create rules that will increase the fraud score. So for example, if the transaction is above the daily maximum amount for the merchant, or it could be, you can create another rule. Let's say if the amount of the transaction is above a certain threshold, then it could increase the fraud score to, let's say, by 10. You can have other rules too. Like for example, if the transaction source IP, so it means that the IP address of the client, and you determine that it's part of a blacklist, then the fraud score can increase significantly. So after going through a set of rules, eventually you need to make a decision. So you can custom and set these threshold. So for example, if you determine that, okay, the fraud score is above a certain threshold, then you can flag the transaction as fraud. And that will complete your decision engine. Now the question is, will a rule-based system work for fraud? It will work. Actually, based on my past experiences, it could work. However, it is rigid and requires reconfiguration. Also, it might not always detect fraud and even make the end user dissatisfied because of false positives. So how can machine learning help? So the machine learning approach is kind of counterintuitive to how you do it when you try to program a rule-based system. So the approach here is you teach an algorithm to determine which transactions are fraudulent and which are not. The technique is called supervised learning, since the algorithm learns from data. You need robust and reliable data to have reliable results. So this is kind of different from how you program in a more deterministic manner, because in this context, you're trying to teach an algorithm through data. So you need to make sure that the data is good in order to have good results. So to better understand what are the other types of algorithms in machine learning, so as mentioned a while ago, we have the supervised learning. You also have what they call the unsupervised learning and the reinforcement learning. So let me quickly give you some ideas of how these algorithm types work. So for supervised learning, as the name implies, it uses historical data to predict for a given set of inputs. So the key here is that you need to have data that you already have curated, you already have cleaned, and you feed this to the algorithm in order for the algorithm to learn what to do given a new set of inputs. So it has a lot of applications. So for example, the scenario I mentioned a while ago for fraud detection, this is generally seen as what we call a classification problem. You can also apply it for regression. So if you want to predict a number, a numerical value, for example, you have past data for your historical sales, and you want to predict, let's say, your sales for next year or a couple of years from now. So based on past data, your regression model could give you a value. The next algorithm type would be unsupervised learning. So essentially, it allows you to find undetected patterns without pre-existing labels. So you can use this to detect hidden patterns, groups, or relationships. So sometimes we call this clustering. And it also allows you to have dimensionality reduction. So dimensionality reduction allows you to lessen the features of your data set. So you might have a set of data that has, let's say, 100 or 1,000 features. But upon analysis, you realize that only maybe 5 or 10 will actually make sense for your model. So having that ability to find the most effective features can be done by supervised learning. Reinforcement learning allows you to have software agents to explore an environment to maximize the reward. So there are a lot of applications, namely for robotics and industrial automation. So the machine learning process, you can think of it as a series of steps in order for you to have a machine learning model and eventually deploy this machine learning model on the cloud. So we start with the business to machine learning problem framing. So the start of the process, you need to better understand if the problem you're solving is solvable by machine learning. So not every problem is solvable by machine learning, or it might be too overkill to solve it by machine learning. So you need to have a good understanding of the problems that can be solved or what the problems cannot be solved by machine learning. So once you have established that the business problem you're solving is solvable by machine learning, then you can proceed with the next step, which is the data collection. So the key with machine learning is that you need to have data in order for it to work. And as part of the collection, you also need to make sure that the data is well formatted to fit your machine learning algorithm. So this is where the third step comes in, which is data preparation. Once the data is prepared, you can perform an initial analysis to better understand the nature of the data and see patterns and other characteristics. So you can perform the data analysis step. Once this is done, you can go to the next step, which is feature engineering. Essentially, for feature engineering, you need to make sure that you have enough features to describe your data set, which is very critical as inputs to your machine learning model. So there might be cases that you need to expand or add synthetic features, or you might need to engineer certain features to make sure that it will fit the model you're planning to build. Once this is established, the step that you need to do it would be the model training. So this is the part where you teach the machine learning model the output or the prediction that you want to achieve. Once the models have been trained, then you need to evaluate the model. Definitely, you want the model to be accurate and you have a sense of confidence with what it produces. So the model evaluation step is critical, and this is where you get an objective metric of the effectivity of the machine learning model. Now, the last part, assuming that you're already satisfied with the results of your evaluation and training, then you can deploy the machine learning model on your platform. Okay, so let's try to better understand this in a more deeper manner. So let's say we want to teach an algorithm to detect fraud. So we can look at our data. So see here in the screen that I displayed here a couple of transactions, and you have the features. So the features are essentially the attributes of your observations. So the features could be source IP, the amount, and the end goal of our model is to predict fraud. So the attribute that we're predicting is called the label. So in this table, we want to designate that as the is fraud flag parameter. So in this data set, you'll see that every row essentially are the data that you want to feed into your model. So you call them observations. So once you have completed the machine learning process and once you are ready to deploy it, the cloud becomes a very good platform to not only build and train your model, but also to deploy it. So when you have deployed the machine learning model on the cloud, you're going to have what we call an inference endpoint. The inference endpoint essentially is an API in which you can call it from your application to make predictions. So at the bottom of my slide, you can see here that I've run the curl command with the HTTP post, and it's hitting the API endpoint. In this case, I developed my model and also deployed it using AWS, using Amazon SageMaker. Unsupervised learning, so going back to the other type of machine learning algorithms, you also have the unsupervised learning, which helps you discover patterns in relationships. So sometimes when you have too much data, you don't know how to manage or how to understand your data. So sometimes having algorithm give you insights is a good step towards better understanding the amount of data you have in your company or in your business. The input data here is unlabeled. And the idea here is that you let the algorithm discover the patterns, the relationships, which could help you in further developing other models or giving you more insights. So for example, if you have, let's say, years of data worth of purchase data worth of for many years, and you want to discover customer segments, then you can use an unsupervised learning to help you discover those segments. You can also use this for other very interesting use cases like handwritten digit recognition. So in this case, we're going to use the k-means algorithm. So essentially, you feed the algorithm the images, and you want to determine if an image is categorized as a digit. So by using the unsupervised k-means algorithm, it was able to cluster or group the digits. So from the algorithm perspective, of course, it doesn't know that it's a 0, it's a 1, it's a 2, or a 3, but it knows that all of these digits belong together because they're similar in terms of characteristics. So you see here the cluster 0, you see that if the algorithm sees that the white pixels are kind of grouped together like in a circle, it means that, okay, they more or less they're like the same. So from a human perspective, you know there's 0. Same thing with the other clusters for cluster 2, cluster 1, cluster 3, and cluster 4. Of course, it's not foolproof, and you'll see, for example, in cluster 3, the algorithm had challenges in accurately clustering the digits 4, 9, and 7. So it means that you need more work to make it more accurate. But on a practical manner, we use more advanced techniques for digit recognition. So you might want to use more advanced techniques such as deep learning. Reinforcement learning is a very interesting algorithm type because it allows an agent to explore an environment to learn how to perform tasks. Agent is rewarded for good outcomes and penalized for bad outcomes. So it has a certain loop that essentially has certain steps. So you have a step for performing the action, and once the agent performed the action, it will get an reward. And because of that, it might change its state. So you go through this loop over and over until it optimizes the state that you want to achieve. So imagine a factory floor. So that's essentially becomes the environment, and you have an agent, a robot, and your goal is to have the robot get to the green circles. So the robot can perform certain actions like going one step in front or going left and right. So instead of programmatically creating a program or a script that will check the squares based on the inputs that the robot is getting, what you want to do is to create reinforcement learning algorithm to let the agent learn how to get to the green circle automatically. So for reinforcement learning, you have a concept of a reward function. And the idea here is that it will try to optimize the best steps or the best route towards the goal by maximizing the rewards. So we can see in this pseudocode is that you can get the inputs. Like, let's say you want to check if what's in front of the robot is a wall or a blocker. So if that is the case, then probably the reward might get deducted or it's less. But if it's a free or it's a clear square, then the reward increases. So over time, the algorithm can discover the best route for the robot to take in order to achieve the goal. All right. So now that we have a better understanding of machine learning on the basic level, then let's discuss machine learning on the cloud. Learning machine learning with cloud services accelerates your journey, so you can build practical solutions to business problems faster. AI and machine learning cloud services are growing, so it's the best time to take advantage of them. So to give a better context, so I have displayed here the AWS machine learning stack, and at the top you see the AI services. So the AI services are pre-built platforms that you can use through its API for domains such as prediction, recommendations, natural language, speech, computer vision, and robotics. So all of these solutions are very easy to use. So most of the time, you just need to feed the data and call the API, and it can perform the prediction for you. Now, if you need more control in the machine learning model, so you want to build, train, and deploy a model, And this is where the machine learning services come in. So you have the Amazon SageMaker, SageMaker Ground Truth, SageMaker Neo, SageMaker Reinforcement Learning, and you also have the AWS Marketplace for various machine learning products by third-party partners. You can also leverage AWS Managed Services to run your Apache Spark cluster. So you can use Amazon EMR. And if you're planning to if you want to learn more about machine learning, you can also leverage services such as AWS Deep Lens for computer vision and deep learning, and also AWS Deep Racer for reinforcement learning. Now, if you're a seasoned data scientist or machine learning engineer, and you want to have more control on how to build, train, and deploy the model, you can go to a deeper level of services. So you can actually still use your favorite machine learning engines and frameworks, so such as TensorFlow, Apache MXNet, and Scikit-learn, and still use the AWS Cloud Services for deployment and other tasks. Deeper level of control can also be achieved by using pre-built Amazon machine images, such as the Deep Learning AMS, which has the machine learning frameworks installed by default. At the bottom of the stack, you have the infrastructure and serverless environments. So using the cloud allow you to have access to state-of-the-art hardware, such as GPUs, CPUs, and other services such as compute and storage services to maximize your machine learning activities. All right, so all of these things are great, but how do you start exactly? So to better understand your role, you need to make sure that you have a clear sense of what you're doing. So you might join this webinar as a business professional, a developer, a DevOps engineer, a machine learning engineer, or a data scientist. So I'll give you some tips on how to start your journey based on your role. If you're a business professional, whether you're an executive, manager, product manager, or a decision maker, the key thing for the journey would be to understand how a business problem translates to a machine learning problem. So it could be, if you look at your company, you might have seen that, okay, let's say that you notice that there might be improvements, let's say, on how you handle customer queries. Perhaps categorizing them automatically can help streamline your workflows. Or you might have massive amounts of data, but they're not fully utilized. So those are scenarios and possible problems that you can take a look into and apply machine learning. If you're a developer, then this is the best time to innovate by adding intelligence to your application. So you can use the AI and machine learning application services to increase the capability of your application. And by doing this, you accelerate innovation and also add intelligence. In parallel, you might want to understand machine learning at the very basic. How you learn how to use machine learning, understand the concepts to better help you understand how to use the more out-of-the-box solutions. If you're a DevOps engineer, it's very important to understand how the ML process relate to cloud infrastructure. So similarly, on how you use DevOps to facilitate faster delivery of your software, you need to understand how to utilize cloud infrastructure to accelerate the machine learning model workflow. So this could be from ingesting the data, processing the data, right? Deploying the machine learning model, up to the deployment of the machine learning model to be used as inference endpoints. There are also other operational tasks when running machine learning models, such as having the ability and setting up your platform to have A/B testing and other scaling activities. It's also important for you to have a ML conceptual understanding. If you're a machine learning engineer already, so you have already good grasp already of the machine learning as a domain, then this is the best time for you to really go deep into the cloud. So this will help you better understand cloud and how it can automate model building and deployment. Consider also a certification for machine learning on the cloud. So one of the ones I recommend would be the AWS Certified Machine Learning Specialty. If you're a data scientist, so you have a very deep level of understanding of the domain, then you can complement that by understanding how the machine learning process and how the cloud deployment processes work together. consider a cloud certification both for development. So you can start with the AWS Certified Developer Associate or AWS Certified Solutions Architect Associate, and move on to the AWS Certified Machine Learning Specialty. As a starting point, you can make use of free resources or low-cost courses all over the internet. In fact, for AWS, you can just go to AWS Training and sign up for the account so you can leverage free tutorials, videos, and other resources to jumpstart the learning. But if you want professional coaching and guidance, our company, Apper.ph, offers the Machine Learning for Cloud Developers, which is scheduled for 3 sessions, and the Machine Learning Engineering Program for AWS Certified Machine Learning Specialty. This is for a program for professionals and individuals who are in the machine learning, engineering, or data scientist goals. So what are the key takeaways? Learning machine learning on the cloud accelerates your journey, and understanding the cloud stack and leveraging machine learning services on the cloud helps you innovate and add intelligence to your platforms and applications. But I won't sugarcoat it. It is difficult, but learn to enjoy. Thank you and enjoy your machine learning cloud journey. So our next speaker is one of the best practitioners in the industry. In fact, we were together in the AWS user group Philippines community for many years. And I'm very proud that this guy is one of the pioneers, one of the heroes, one of the few AWS machine learning heroes in the world. Right? So you guys are very fortunate to gain knowledge from this very talented and world-class individual. So I'm very proud to present to you our next speaker, Mr. Joshua Arvin Lat, AWS machine learning hero, and the CTO of Jepto and CBO.
All right. Thank you for that, Diwa. I'll share my screen. Okay. All right. So good day, everyone. So I'm Joshua Arvin Lat, and I'm one of the machine learning heroes around the world in AWS. So basically, my topic for today would be pragmatic machine learning. So I'm going to share a couple of examples. I'm going to share some areas where I think would be good to discuss, and at the same time, I'm going to show a quick example on how things work in real life versus some examples that's usually just stuck with theory. So I'll also have examples with implementing or using certain machine learning frameworks or deep learning frameworks, because I think some of us would probably go straight to those things without understanding the nitty-gritty details when dealing with statistical learning or machine learning or data science requirements. All right, so a quick introduction about myself. So I'm the machine learning hero. So for the past couple of years, I've been dealing with all of these things, and at the same time, I'm making sure that we get to help a lot of professionals around the country to know more about how machine learning works in the real world. So a quick intro would be what's machine learning anyway? So this is just going to be a 2 to 3 minute intro so that you'll have a better understanding of how machine learning works. But let's say that the objective of, let's say, your program or your function is to detect if an image is a cat or not a cat. So to put it simply, it's a cat detection function or system. So it may not have it may not be a good use of it may not be a good example, but this is a really good example because it's not a straightforward process. When creating applications using a computer or creating programs, it's not really a straightforward process because there are different ways a picture may look like. And if you're a human, it's easy for you to detect that this is a cat. But if you were to automate things, it's not easy to detect that this is a cat. So you'll need to make the most out of computer science, statistics, data science, math, and all the other things just to get something like this to work. So there's something called supervised machine learning, where you have this data, training data, and you feed that data into the system. And that system will train or prepare a model that would predict if a new image is a cat or not a cat. So, so let's say that I have this new image here, which is not really part of the set of images I use to prepare that quote-unquote model. Then I would be able to use that model to predict that this cat is an image. So of course, this is a really simplified example, but what you can see here is that it's not a simple mathematical formula that allows us to get a computer to do something like this, but there are lots of applications that can be solved using similar strategies. So these are some of the other problems solved by machine learning. Technically, the problem solved by machine learning is more or less infinite, because because machine learning, the topic on its own, is evolving every single year. There's of course the rise of cloud computing, rise of quote unquote big data, which contributed to this rapid change and the development also of the machine learning tools, frameworks, and techniques. Because what I can say, what I can share here is that this is not just hype. There are of course certain buzzwords in the past where they're just hype, and then when you jump into those, when you try to read and try to learn and even have your career bended because of this buzzwords and hype stuff, there's that tendency to get confused on what's really important. But what you can see here, that there's a lot of problems that machine learning can solve, and that includes anomaly detection, product recommendation, forecasting, image and video analysis, and so on. There are different ways to solve a problem, but the more tools you have and the more techniques that you have, it allows us humans to solve the problems better and easier, and maybe sometimes in a much shorter period of time, or maybe in a more accurate fashion. So I'm going to talk about theory versus practice. So let's ask ourselves the question first: can I build an intelligent system in 24 hours? So intelligent meaning, let's say, with the examples I provided earlier, let's say fraud detection system. Let's try to find a way where we don't need to have humans take care of the nitty-gritty details, and just have a computer accept inputs, and then it just returns an output, and basically it does the automated stuff behind the scenes. Let's say that there's product recommendation. In the past, probably 4 or 5 years ago, trying to answer this question is hard, because at that point in time, even the countries outside the Philippines is having a hard time dealing with all of the requirements. So when you're trying to build an intelligent system, definitely there's the data science and machine learning part, and then there's the engineering part. So when you have those two things, and you need to build something like this, and you have a really you have a team, and then this is basically a project, and your company is trying to invest its resources trying to build this thing. There's that machine learning and engineering problem, and right now in 2020, it's called machine learning engineering. But if we take a step back and try to answer this question, can we really build an intelligent system in 24 hours 5 years ago? Maybe not. Maybe the best can do that, but I think most of the professionals and teams around the world would probably take 1 to 2 weeks, or even 3 months to build something like this, and that takes and that's a long time. If we were to answer the same question right now, the answer would probably be probably we can do this in 6 hours, staging or production, because I think the tools and frameworks and resources available now are plenty. So if you ask yourself, really, is that really the amount of time to build an intelligent system? Because I think that's complicated or complex. There's that assumption most of the time, but I think that you can do this in 24 hours because because I've done this. We've tried it. There are tools available, and I'll share a quick example later, probably 3 or 4 slides, where you can see that you can now create a quick POC in just 15 to 30 minutes. That's because I already know the system in and out. But for a beginner, let's say a young professional who's new to the tools and frameworks, maybe 6 hours, but it's still less than 24 hours. So if you know this, if you know that it can be done in 24 hours, when you're a C-level executive or you're a tech manager, your mindset and perception about how things work will change. Because if you still think that it's going to take 3 months, then you probably already lost the competition. Because the world right now, especially now in the COVID situation, it's definitely a trickier place to live in. And the challenges now are basically harder because competition is harder. The resource, and then in terms of like productivity and the resources available, they're all affected. That's why we need to always have an edge. And if we don't even know that these things are possible, how can we have an edge? How can we have the opportunity to make the most of what we have, especially if we're not even aware of the options? So the goal of the services. So these are just these are some of the services that AWS has. This can easily apply to all other platforms, but it's more of like how you deal with these tools and services or frameworks. The usual tendency of a company or a professional is to always just choose one tool, stick with it, and try to solve a problem using a single tool. But if all you have is a hammer, everything becomes a nail. And my suggestion there is for everyone who's able to watch this video, to basically try to research first before doing things. Of course, getting your feet wet is important, but what if the problem that you're trying to solve has already been solved? And if you're trying to create your own startup, the challenges there, if you're not trying to do your research first, is that maybe there's another competitor that's trying to solve the same thing, meaning that all the work that you put in for the past 3 months would go to waste. So yeah, so in addition to doing research the tools also, because if you're thinking that something can be built in 3 months, when in fact it could be built in 3 hours, that's a really big difference, because your company may run out of funds even before it gets to launch. So when we have your tools and services, the goal there is to focus on your goal, meaning that the tools and abstraction layers would help you solve the stuff that other professionals and teams have encountered before. So that's why we have these tools. And you have your custom logic somewhere in your application, which basically solves the problem that your company or your project is trying to deal with or solve. So this is the AWS machine learning stack. So there are 3 layers here, but there's always that misconception that if you're a developer, then you won't have the, and let's say you don't have the idea or any idea on how data science and machine learning works. There's always that tendency to stop and let's say, oh, I'll need to spend 2 years training, studying before I try out machine learning. That's not true, because even if you're someone with, let's say, 1 month or 2 months of dev experience, you can make a lot of these things work for you even with very minimal machine learning experience. Of course, it's limited, but once you get to try things out, you'll be able to understand the things which are really happening in production. So what do I mean by that? So let's say that I want to build a system that processes image, and then it processes the images and then returns if the person in that image is smiling or not, or if the person in that image is male or female, child or adult. So here you can use something called recognition, and it will probably take someone, let's say a mid-level developer or engineer, 4 hours to 6 hours to get a proof of concept to work and get something deployed into production in 2 to 3 days. That's the average case. Maybe faster, maybe slower, but it's not 3 months. Okay, so years ago, probably 3 to 6 months or 2 to 3 months, but right now, you have to know that it can be completed in 1 to 2 days or 2 to 3 days. And these services are solving different things. if you want text to speech, speech to text, all of those things can easily be solved with 5 to 10 lines of code, which I think most people are not aware of. The ML services, on the other hand, allow us to solve more complex and more custom problems. So let's say that you already have a model, you have to do retraining. Let's say that you want to do automated machine learning. Let's say that you want to make the most of automated hyperparameter tuning. Then that's possible using the ML, quote-unquote ML services. They just called it ML services just to have a group for this one. But this one allows us to make the most out of the building blocks here and solve the more complex and more custom requirements. So you can do training and deployment, or let's say that you have your model trained already and you just need deployment, then you have model hosting here. All right, so now that we know more about what the options are, if you were a problem solver, if you are a solutions architect, an entrepreneur, a machine learning engineer, this would help you solve your problems in a much faster rate. There's always that tendency to specialize right away. But I think that the more important thing when dealing with data science and machine learning is listening to the customer's needs. So what if you spend 3 years of your life trying to study one domain, and then it ended up that the world needed something else? Of course, there's pros and cons when trying to master something versus trying to know a lot of things. And I think it's a good mixture or a good balance of it is critical. But when you're trying to have your startup to have your startup succeed, you're going to do a lot of trial and error. And maybe after a couple of months, you realize, oh, I have to pivot. So let's say that your product recommendation startup didn't work, and you spent 4 years on that. That's sad. But what if you only invested 1 month on your product recommendation system, and then it didn't work? Then that's the negative. But you can already move on and move to forecasting. So let's create a system that does forecasting, absorbs this data, and tries to predict the future. And you spend 1 month on that, 1 month of your resources on that. And you can even save a lot more money because the time of your the time spent by your team is critical here. What if you can solve all of these problems in just 2 or 3 days, or 4, or even less? So what if there are solutions available already? So for anomaly detection, maybe you can check SageMaker random cut forest algorithm. If you are dealing with data that's streaming data and you're passing it through a service called Kinesis, then there's also that option to use machine learning in SQL. So those things, if you're not aware of those things, if you're not aware of the solutions, there's always that tendency to create your own custom solution, which sometimes may not be the best option, especially if you just need something to work. Sometimes doing things the custom way, which I've tried a lot in the past, takes a lot of time. Let's say 1 week, 2 weeks, and then if there's an error, sometimes it's hard to look for the solution in Stack Overflow. So for those developers watching this already, also, you'll know the pain points. But when you're using a system or tool which is already working for a lot of people, and it's well documented and it's working, it's stable, then that's where it shines the most. Let's say product recommendation, you can check Amazon Personalize, and so on. So these are just the solutions right now here. But there are, of course, other alternatives, and probably this list would change next year and next year. What I'm saying here is that when you're trying to solve problems, try to look first at the problems that you're trying to solve. First step is to check if that's what your customers really need. And then try to list all the possible solutions. This is just one solution for this one. Try to have different solutions and then compare and contrast which one is better for your current situation. So this is one example. Let's say I want to translate English to Japanese. So I'm not good in Japanese, but this is a good example. So what in Japanese I think is nani? Yeah. So for those watching TV shows in the past, you'll always hear that translation. when you watch something in Japanese. So before, say if you were to try to build this on your own, you have to know how to speak and write the Japanese language. But I don't think we have time for that. So it would be better to just use a service for that, because I believe that that would be more accurate. That would have more accurate results, and instead of trying to build this on your own. So you create this API endpoint with using an API gateway. You have a lambda function, which is serverless, and then it connects to the Amazon Translate service, and then Amazon Translate service just receives the English what, and then returns the Japanese nani, and then returns it back to the user, or to the system performing that request. Meaning that it's really this simple right now, because you may end up having a really complex system, really large bill in your infrastructure resources, when in fact this problem has already been solved, and there may not be a need already. There may no longer be a need to even spend 6 months to 1 year trying to do the same thing. So earlier I talked about machine learning and machine learning engineering, and this is something which is missing, I believe, in the Philippines especially. In other countries, when I had my talks there, I think this past couple of years, because when we had this COVID situation, of course, everything stopped. We all had to stay at home and stop traveling. But when I was traveling this past couple of years and doing my international talks there, I thought that I did feel the gap between the opportunities there and the skill levels there, the capability and skills there, versus the opportunities and capability here in the Philippines. It's not bad, but more of like there's a void. There's an opportunity here in the Philippines where there's really few people who's really good in machine learning. There's few people who we can say are really good in engineering, because some say, oh, I'm an expert, when in fact they only have 1 year of experience and they have used only 1 or 2 tools or frameworks. But being an expert takes a lot of years. And being an expert in both machine learning and engineering, those are really hard to find. Probably you can count the number of machine learning engineering experts in the country, probably at most 5, I'm not sure, maybe 10. But it's really few. And what I'm sharing here is that knowing this and having this capability right now or over the next 2 months or 3 months would definitely not help you as a professional, but that would help your team, your company, and it would help your customers and your clients. And that would either help your company or help the people around you. Because once you have the working examples, once you have those processes in place, then you can just replicate what has ever worked for you with other projects. So this is one example. This is another example. Let's now talk about how to use the machine learning and deep learning frameworks with Amazon SageMaker. So when someone is trying to learn machine learning, they won't always look for the production level stuff, because the tool and services that I've shared are mostly focused on getting things done in production. And usually the blocker there for most users is that they try to study machine learning, data science, and statistics, and try them out in their local machines. And then when they're planning to deploy it into production, then they realize that it's not working, or they have no idea how to do so. So sometimes when you try to learn this by yourself, let's say you're trying to study TensorFlow, Keras, PyTorch, Gluon, Scikit-learn, Chainer, MXNet, maybe next year there's a couple more frameworks or libraries, or even a couple more frameworks and libraries. Then you start with your model training in your local machine. But once you have larger data sets, of course, your local machine would break. You won't be able to do that. And that's why you have to do your training and deployment in the cloud, let's say in AWS. So there are a couple of options. These are a few ones. You have your built-in algorithms, where you just put in a couple of lines of code, you pass in the training data, update the configuration, and then do training. There's also your option to bring your own container, where you have full control of everything, the environment where your script is running, and also the behavior of your um, endpoint, your inference endpoint environment. And then you also have your option to bring your own algorithm. Let's say that you've already been using a famous framework like TensorFlow, PyTorch, Apache MXNet, Keras, Scikit-learn, Gluon, etc. Then your code can easily be ported to SageMaker and get it to work with very minimal modification. Meaning that if your script is not cloud ready, you can easily make it cloud ready with just 2 or 3 lines of code, which is something that I was surprised that there was this option that isn't really that well known, especially for most of the machine learning and machine learning engineering practitioners. So let's say that you have a script in TensorFlow and Keras, for example. Then having this 5 to 10 lines of code, of course, I have removed some of the lines, but this is the simple way of looking at this one. You have a script with your training script, and then you just create an estimator, and then you perform training. So you use the fit method, and then after doing training for, let's say, 5 to 10 minutes or even more, then you perform the deployment. The advantage here is that the code is different from the infrastructure part. Because when you're trying to solve a problem, there's always that limitation or blocker when your infrastructure cannot support the processes that you're trying to run. And having all of those skill sets usually take years or even decades of practice before you can learn how to do machine learning and when you can do engineering. Because when you have to learn about engineering, you have to know about blue-green deployments. You need to know system administration. You have to know how to handle the servers. You need to do automation, etc. And when you're trying to confuse the custom logic code with the server stuff, then you're going to probably spend 2 months, 3 months just trying to get this thing to work, and updating it would be super hard. But if the infrastructure part is abstracted, you can focus on your custom code and custom logic. Because here, one of the parameters is the size of the server or computer or virtual machine that you're going to use. Let's say that a small one is super slow, then you just change it to medium or large. Yeah, so that the good thing there is that you have full control over the cost, and you have full control over what you want to use. Because after you have run the training job, instead of you trying to pay for 1 year of infrastructure resources, you're just going to pay for the minutes the computers are running in the cloud. And you don't have to worry it here because it's automatic and abstracted by this one line of code. And all you need to do is pass the training input. So if it seems complex, that's fine. But all I want to share here is that it's easy, especially if you can see that there's a pattern when trying to solve these things. So as you can see here, you initialize the estimator, you do training, you do deployment, and you do a prediction. And more or less, it's the same lines of code. As the tools right now usually provide an SDK or a software development kit that abstracts the API for you. All right, so we're almost done. And I'm going to share an example on how to use the SageMaker built-in algorithm. So earlier, we had an example where we tried to use TensorFlow and PyTorch in SageMaker with SageMaker. Of course, I've removed the details and creating the neural networks, preparing the architecture, extracting and checking the weights and biases. But yeah, that's just a quick example and sharing that a lot of people have no idea that it can easily be deployed in production, even if you perform the model training in your local machine. So here, we're going to make the most out of the SageMaker built-in algorithms. The reason why it's built in is that the system itself, the service itself, provides, I think, 16 to 20, somewhere between 16 to 20 algorithms for different use cases. All right, so the goal here is to have us deal with a quick example using the built-in algorithms of SageMaker. So there's something called topic modeling with latent dirichlet allocation. No need for us to go into the details of how this algorithm works. But let's say that you have a couple of documents, and the goal here is for us to have something like this at the bottom, where once we process the document into a format that the algorithm can process, then the end goal here is for us to assign if a document falls under a certain topic. So you process text, and then out of nowhere, after you've used the algorithm for inference, you'll get a 70% rate, 70% chance that this document falls under this topic. That's that's a simplified way of thinking about this one. So let's say that I have a document about basketball. I have a document talking about volleyball, for example. This one about chess. Then this technique can easily automatically assign a document to a specific topic, which is cool because sometimes when people think about these things, thinking about the applications of machine learning, they always think about, okay, it's probably image processing, or maybe we're just dealing with numbers, or let's say regression. But here we're talking about text. And even if there's no human trying to map these documents to specific topics or tags, an algorithm can do that for us. Meaning that, let's say that you have a book with a lot of pages, or let's say that you have Wikipedia and you want to do automated tagging of topics there, it can be done using an automated script. So here, like what I shared earlier, there's just a couple of steps, high-level steps that we need to think about. There's pre-processing, there's SageMaker training, there's SageMaker deployment, and inference. So what I'll share here is that usually people try to complicate these things because they're using a lot of tools and frameworks. Of course, you can do that, especially if you want to optimize. But if you want to get something done in 6 to 24 hours and you have no idea what you're doing, the first thing you need to do is find something which tries to solve all your problems first. And then when you have that large umbrella working, at least you know that the problem that you're trying to solve is solvable. And you can do that in X amount of time with X amount of resources. And then all you need to do next is optimize, replace this specific part. Let's say I don't want to do training here. I want to use another tool or another service for it. Then do that. What's important here is to be very practical about things and making the most out of the tools and options available for you. This is the sample code. So what you can see here is that you just do, you initialize. You just prepare the container and pointing to the algorithm latent directed allocation here. The next thing that we need is the input data. So this is the expected input data of that algorithm. And then we store that data, that input data, into S3, which is a service for storing data. So what we're just doing here is that we're just initializing the estimator that represents the training job, the estimator that represents the training job with all of these parameters. As you can see here, the training instance type is MLC for 2x large. If we see that the training job takes a really long time to complete, and we need things to complete in a much faster time, then we just update these parameters. If you want to change the algorithm, we just change this image name. So the advantage there, as you can see here, is that if we see that there's a pattern, then that means that all we need to have next is a collection of algorithms that we can use. And that's why there's built-in algorithms, meaning that if you can solve this problem in 3 to 4 hours, then maybe all the other problems can be solved almost at the same time, just as long as you understand the problem that you're trying to solve and as long as you understand the data. You set the hyperparameters, and then you perform your training job. Really simple. And then you have something like this in your UI, and yeah, and so on. So here you perform your deployment. So when you have been working for a long time in this industry, and then you see that your deployment needs can be solved with one line of code, then you'll realize, okay, do we really need to invest in a super large engineering team, especially if we're at that point where we don't have the budget yet and we're still checking if the idea is working. Because when you're working in a startup, there's no guarantee that your idea will work right away. The goal here is for you to build something in a really short period of time, let's say 3 days to 5 days, deploy it, and then have the customers or your clients use it first. If they're happy, then go optimize. If they're not happy, then change strategy. Don't try to force something which isn't working. Yeah, so So there, and then when you have to do prediction, it's just one line of code also. So what I'm sharing here is that a lot of things have been automated already for you. And the only thing that matters now is the idea that makes your project or startup different. So meaning that all the tools that I've shared, all the examples I've shared, tells us or basically allows us to solve problems which are custom to us or the startup. So that instead of us trying to solve problems which have already been solved, let's focus on the things which haven't been solved yet. Yeah, so basically that's it. Once you run that R script, you can also use Python with that. Once you pass in the input, you'll have something like this. And then when you analyze things, okay, this document belongs to this or has this specific topic in one of its words or something. Document W can be tagged under topic 2, document X, topic 5. Then yeah, this system may work for most types of documents. Maybe a few tweaks will be needed. But what I can share here is that it's pretty cool that you can process text and even summarize a document using a text summarization algorithm. There's a lot of applications for machine learning, and what I'm sharing here is that a lot of people think that this is hard. A lot of people think that this is very technical. Yes, it's technical, but it's not super hard right now compared to how it was 10 to 20 years ago. In the past, 15 years ago to 10 years ago, offensive security is hard. But right now, the resources out there, there's so much. Same with machine learning, a specialized topic in the past. But right now, there's a lot of resources. And if you don't start now, you will fall behind. Because I feel that over the next 10 to 20 years, machine learning will play a big role into the strategies of different companies. Because even if you don't notice it, you can see that your phones are already using machine learning there. Your computers already have machine learning trying to solve a specific problem there. It's like coding, where a lot of people learn coding as a specialized skill. A lot of schools right now are trying to force students to learn how to code. And maybe machine learning in the next 3 to 5 years, it may be required because of the applications that it can do. So yeah, that's the end. Thank you very much for listening. Hope you learned something. But before I end things, the more important thing here is the word excellence. It's not enough that you're normal. What's critical here is that you're excellent, you're amazing, because excellence in machine learning engineering gives businesses and professionals an edge. So thank you very much and have a great day ahead.
All right. Thank you so much, Arvs and Diwa. And we would like to thank our wonderful coaches for that very insightful session. And we hope all of you found new learnings and knowledge from the session that we just had. And before we continue to, before we open the floor for questions, I'd like to introduce also, since we've talked about machine learning on the cloud, and our speakers gave you an introduction. We'd like to take this opportunity to introduce the programs that Apper is actually offering on machine learning. So we actually have 2 programs, which is the Machine Learning Engineering Program and the Machine Learning for Cloud Developers, so our MLEP and MLCD programs. So what is MLEP? So Apper's Machine Learning Engineering Program for the AWS Machine Learning Specialty Path. This is actually an intensive and hands-on coaching and mentorship program that prepares data scientists, data engineers, and software engineers to build, train, and deploy machine learning models on AWS. And most especially, this program prepares participants to complete and gain the AWS Certified Machine Learning Specialty Credential. So just for an overview, the program is designed and optimized to prepare data scientists, machine learning engineers, and DevOps engineers for the AWS Certified Machine Learning Specialty exam in 7 sessions. So the 7 sessions are from 9 a.m. to 4 p.m. every Saturday. So we've actually started the program already. We've started in October 3. So we'll keep you updated on the next schedules that we would have for the next upcoming cycles. And of course, a briefer on the inclusions that we have for the program. We have 7 sessions, of course, facilitated by Southeast Asia's sole AWS Machine Learning Hero. We have 23 lecture and 15 lab activities for you. And of course, 5 quizzes to check your knowledge. And of course, you have all of these inclusions such as access to AWS, access to Springboard, and then of course, this already includes the certification fee and practice exam, post-program support, and of course, membership to the Upper Certified Cloud Professionals Network for post-program support. We would love to welcome you to our community of certified cloud professionals. So just a quick briefer on the 2 different programs that we have. We have the MLCD and MLEP, which differs. Like the machine learning for cloud developers is kind of like the light version of machine learning engineering program. And we have the prices here. So MLCD, it's composed of 3 sessions. So it's really more on learning the fundamentals of the AWS machine learning offerings. And then we have the machine learning engineering program, which would prepare you for the AWS machine learning specialty exam. And we have, for those who would be registering early, we also have some exciting discounts and the pricing for you. So for more information, you could visit our website, www.apper.ph/MLEP, or you could send an email inquiry to you could send an email to cloud@apper.ph. All right, so for those of you who are interested to gain more in-depth insight and actually prepare to be certified for the AWS machine learning specialty path, please do send us your inquiries. We'd be glad to assist you as you start your journey on machine learning. All right, so we now open the floor for your questions. So for any questions that you've been itching to ask since the start of the session, please do type it in the chat box, and Diwa and Arbs will be available right now to answer all of your questions and queries. So don't be shy, we don't bite. Please feel free to type in your questions in the chat box. Thank you. All right, thank you so much for everyone who participated and attended this session, the Intro to Machine Learning on the Cloud with Apper.ph, of course, in partnership with Kubo Philippines. We would like to thank our partners for the opportunity to share our knowledge with each and every one of you. And we hope to see all of you all throughout the PH Startup Week. We have exciting things for all of the startups here right now. And we hope that you found the session insightful, especially in the new normal as startups power up the new normal and everyone's adjustment. This is the perfect time for tech innovation, for digitalization. So we would like to thank everyone who attended. And of course, definitely we would want to thank our speakers for today who shared their knowledge and expertise, Mr. Diwa Del Mundo, co-founder and president of Apper.ph, and of course, Mr. Joshua Arvin Lad, the AWS machine learning hero for Philippines. Thank you so much, and we hope to see you around. For any inquiries, please do let us know. We'd be happy to help you. Thank you. Have a good day and stay safe.